Euclidean geometry. Well, now this is a new topic that we are going to be discussing. It's called Euclidean geometry. And before we look at Euclidean geometry, what is it that we want to know about geometry? In other words, what is geometry? Well, geometry is a branch of mathematics which is concerned with the properties and relations of points, lines, surfaces, and solids. You know, the relationship that comes to be because of the presence of points, because of the presence of surfaces, points, lines, and solids. That type of relationship leads us to the study of a branch of mathematics which is called geometry. Now, geometry is divided into two. Geometry is divided into Euclidean geometry and analytical geometry. In this section, we will be looking at Euclidean geometry. That is the geometry that we would like to look at. And now, what is Euclidean geometry? Well, as I indicated, geometry is divided into two. That is Euclidean geometry and analytical geometry. Now, analytical geometry deals with space and shape using algebra and coordinate system. That is analytical geometry. That is not what we are going to be studying now, but it is important for you, at least for the start, to know how these two are related. Now, on the other side, Euclidean geometry deals with space and shape using a system of logical deductions. Euclidean geometry was first used in surveying and is still used extensively for surveying up to today. Euclidean geometry is also used in architecture. That is, for those of you who will want to become an architecture with time, those of you who will want to study and become engineers, architects, designers, you need to know that Euclidean geometry is going to be very important for you because Euclidean geometry is used in architecture to design buildings. Other uses of Euclidean geometry are related in art, that is artwork, you know, where there is things like drawing and painting and stuff like that. Also, to determine the best parking arrangement for various types of objects, we also use Euclidean geometry. So precisely, that is for the introduction of Euclidean geometry. Now, the first thing we want to look at is the concept of angles. I've already indicated that the relationship that exists, or the relation between lines, between planes, between surfaces, between solids, leads us to the study of Euclidean geometry. Now, the first concept we would like to look at, after now getting to know what Euclidean geometry is, the concept of what? Is the concept of angles. What are angles? How are they formed? Now, the interesting thing here is that angles are formed when two lines meet. If two lines can meet, then the measure of space between the two lines is what we call the angle. Now, in this line segment, or in this diagram shown, we have the line segment AC and the line segment AB. Now, these two lines met, and we see an angle formed at the point A. This measure of space between this line AC and AB, this measure here is called an angle. An angle is mainly formed when two lines are meeting. That is when an angle is formed. And so we can say angle at point A, or simply angle A, is this. And there is also how we write angles. After understanding how angles are formed, it's very important that we understand how do we write it. Well, angles are written with a letter. That is, they are represented with a letter with a caret on top. So, for example, angle A will be written as, that is, A will be written as A with a caret on top. you know, there is something which is put on top of that. This will lead us to an expression like this. So this is how we write angle A. Now notice that instead of writing it as A with a caret on top, we could also write it in some other way. For example, we could say angle A is equal to this second way of writing angle, specifically angle A, is with the help of the line segment leading to the formation of the angle. That is, we now have to look at CAB. And so we can say angle A can also be written as CAB, with A, the middle letter, being the angle. In this case, we still write A with a caret on top. So this is how we do what? This is how we represent angles. There is another way of writing angle also. Okay? We could talk of angle A. That is, A can still be denoted as, well, in this denotation, we use a letter or a symbol which is close to L. So let's see the symbol right away. Yes, this symbol is also used to represent an angle. So we could say angle A. So when you see that there is this letter or there is this symbol used before a letter, just know it is indicating an angle. So at least now we know how to denote an angle. Okay, we now know how to represent, how to write it down, how to write an angle. The next thing we want to look at is what is the unit of an angle. For example, if angle A is 37 degrees, okay? If angle A is 37 degrees, 37 degrees, how else can we represent it? I mean, if we know angle A, how can we write that value which we already know? Now, notice that in the first case, second case, third case, we have been representing what? We have been representing these angles. How? Without a number. The next thing we now want to look at is, what if we already know the value of the angle? How do we represent it? For example, if we know that angle A is 37, how do we write that? Well, A being 37 will be written as 37 with a unit on top, and this unit is called a degree. So yes, if we already know the value of angle A, then what we do is we write the value with a small notation similar to the letter O or similar to the number O on top of the number written. Okay, so this small O that we have up there represents a degree. So these are the different ways we can denote what? An angle. So now that we have seen how an angle can be written, okay, these ones are called notations. Okay, these ones are called notations. Yes, they are known as notations. Now the next thing now we want to look at is, when we are done with the notation, how do we determine these angles? Okay, so this got some, yes, all right. So there was a small command button that sent us to a new page. Yeah. So now that we are done with the notation, the next thing we want to look at is angle properties. Okay, this is the next thing we want to look at. It's called angle properties. What are some of the properties of angles? Okay, well, in angle properties, a few things we are going to investigate. There are a few properties we are going to investigate. Look at the angle indicated right here. Okay, now notice one thing, and that there are two lines here. There is this line which extends all the way up to here, and there is another line which extends all the way up to the other side. Well, these two lines meet and they still continue to go. Between them, we have angle A, angle B, angle C, and angle D. Now, we would like to investigate how are these angles related? What are some of their properties? You know, that is one thing we want to know in this investigation. Well, to make it a little bit easy to understand how these angles are related, look at how the lines indicating the measure of the angles are marked. Notice that there is a similarity here. We have two lines, you can see for yourself, and we have two lines there. That means A and C are related in a special way. Also notice that the line indicating the measure of B, that is angle B, is related to the line indicating the measure of what? Of the point or angle D. Because we have one line here and one line there. Well, what that is supposed to mean is B and D are also related in a very special way. Now, we would like to talk of them using the concept of vertically opposite angles. Okay, now when we look at angle A and C, which is to the right here and to the left, notice that we can bring that as this. So using this extract here, we have this and that, which is indicating A and C. Now we have seen that A and C are related, but here it's being expanded and it's a lot easier for you to see. So because A and C are related in a very special way, we also say angle A and angle C are not only related, but they are also equal. They are called vertically opposite angles, just like this other one here. So let's start with A and C. So in that case, we say, well, angle A and angle C are what? Are vertically opposite. Yes. Okay, now let me put the notion of the caret right on top. So this is for angle C, yes, and also we have for angle what? For angle A, yes. We have to write it the right way. So angle A and angle C are vertically opposite angles. That is not all. Angle A and angle C are also equal. They are equal to each other. You know, they have the same value. That is one important property which you yourself, you can also prove. How do you prove that? Well, just draw any two straight lines. Just like this, draw a straight line and draw another straight line. And use a protractor to measure this angle. Then also measure the other angle. In your conclusion, you will see that these two angles are the same. And so we can say angle A and C equal to each other. Yes, that is one. Those are 2 points. Now the other thing we want to include in our investigation of angles is now these two, this upper one and the lower one, which is still investigated under the concept of vertically opposite angles. Now for these vertically opposite angles, we have B and D. Now for these two, they are also vertically opposite angles. And because of that, well, we include it here. So we say angle B and what? And D. Vertically opposite angles. Excuse me. So yes, we say angle B and angle D are vertically opposite angles. Well, let me put it in the angle notation. Yes. Now, the other thing is that angle B and angle D are not only vertically opposite angles, but they are also equal to each other. And because of that, we can now have this replaced with equal sign. Well, does this make news? Is this a big thing for us? It is. It's obviously a big thing. From these four properties of these four angles, we can look at a sample question. Well, maybe before we look at one sample question, let's introduce one more concept. But yes, we would like to introduce one concept. Now, notice that our calculation of this activity is going to come after the introduction of one more concept. And the concept is right here in the table. And what is that concept? The concept is about the angle on a straight line, sometimes known as straight angles. Well, the question is, what about straight angles? How about straight angles? Well, it turns out that angles on straight lines, also known as straight angles, add up to 180 degrees. Well, what's that supposed to mean? That's supposed to mean angle A and angle B, also angle B and angle C, add up to what? To 180. Well, let's get back to this. What we are saying is that angle A and angle B add up to 180 degrees because these two angles, they are the angles on the straight line. Well, angle C and angle D also add up to what? 180 degrees. Why is that so? It's because they also form angle on the straight line. The only difference is that they take the lower bit of the angle, while A and B takes the upper bit of the angle. Now notice that is only for one line. Should you introduce the second line, which is this other one here, you will soon notice that angle B and angle C are also angle on a straight line. And because of that, they also add up to what? To 180 degrees. And also, angle A and angle B forms the lower bit of the angle on the straight line. Now that means angle A and angle D also add up to 180 degrees. So in a much more simplified way, under these properties, we can then go ahead and say angle A and B, that is angle A and B, that is A plus B, add up to 180 degrees. So let's first put them with the right notation. So here we go, B and what? And A. What do? They add up to 180. 180 what? 180 degrees. So we have it right there. Now, the other property is that this other angle, well, we could decide to make it clockwise instead of just jumping around. Let's say A and B add up to 180. Then also C and D adapt to what? C and D also adapt to 180 degrees. So we say angle C added to angle D also adapt to 180 degrees. So there we go, 180 degrees. So with the right notation, we now take care of what? We take care of C. Then later, we take care of what? We take care of D. Well, now that we are done with this angle, the next thing we want to look at is the concept of one more angle, which in this case is what? Which in this case is based on this line here. So we will then say angle B and angle C, okay? Angle B and angle C, these two, B and C, which are two angles on this straight line. They also adapt to 180 degrees. And so because of that, we go ahead and say, as next point, angle B added to angle C should give us 180 degrees. Okay, so there we go. B with a caret on top of it, and then C with a caret on top of it. Well, the next thing we want to look at is the other angle, which is what? Which in this case is C and D. Okay, we have now seen B, D. Oh, CD is already there, so we instead go to what? D, A. So there we go. It will be like angle D added to angle A should give us 180 degrees. So we say angle D, that is D with a caret, then also A with a caret should add up to 180 degrees. So there we go. We now put the degree and also one here. Well, these 6 properties, that is the first 4 properties plus the next 4 properties, they form a very big part of angle properties, okay? They form a really big part of angle properties. And now, we would like to see how we can apply these angles, okay? How we can apply the concept that we have just looked at. And how do we get to that? Well, with these 8 properties, we would like to look at a sample question. And what is that? Well, the sample question here is coming from this activities 1, 2, 3, 4, 5. Well, I would prefer to start with these last 2 before I get back to that. So let's talk about angle C, D, E, and 140. Now notice that angle 140 degrees is indicated with this blue, and it is vertically opposite to angle D. By which property? Well, by this property here, or this other property. They are vertically opposite, and also they are equal to each other. So if we are going to call this activity 1, then we will go ahead and say for activity 1, okay, this is now an activity 1. Now in this activity 1, what we are supposed to do is to find the value of angle D. I'm going to break activity 1 into part A, in that order, part B, okay, then part C, then part D, then part what? Part E, okay, because we have 5 questions in activity 1. Well, now the first thing here is that D 140 degrees are vertically opposite angles. Okay, so we start with that. D and 140 are vertically opposite, and also they are equal to each other. And so we can say angle D, okay, that is D with a caret. D with a caret. Where do we find the caret? Right here, yes. Okay, so D with a caret should give us the value of what? Should give us the value of 140 degrees. Okay, that is 140 degrees. And that is all. Okay, now, now that we have got D, the next thing we want to look at is C. Or we could have got C first, then D, then E. How would we have got C? Well, we would have got C because C and 140 degrees, they fall under angles on the straight line. That means C and 140 add up to 180 degrees. So let's start with that. Okay, let's start with that. If we start with that, we will be like, well, C, okay, added to 140 degrees must give us what? 180 degrees, okay? So we will have C with a caret on top right here. At any time, we want to have the right way of writing these angles. So we will be having that, and then 140 is the angle in degrees, and also 180 is another angle in degrees. That is the total of the angle that you find on a straight line. Now that we are done with that, the next thing we want to look at is what would be the value of C. All right, let's do it this way. So to find the value of C, what we do is we to do what? We collect like terms. In other words, we transfer 140. We transfer this 140 degrees to the right-hand side. That means on the left-hand side, we are going to be what? We are going to be left only with C. So if we are left only with C, we will be having C now equals to what? C this time equals to 180 degrees minus 140 degrees. Okay, that is 180 degrees minus 140 degrees. And so from here, can we find the value of C? Yes, we can find the value of C. The value of C will be calculated when we minus or when we take away 140 from 180. And so in the next step, we then have what? In the next step, we then have C, okay, now equals to what? 40 degrees. That is what we get when we do what? When we minus 140 from 180. And that is how we get the value of what? That is how we get the value of C. All right. Now that we have got the value of C, the next thing we want to look at is what? The next thing we want to look at is the value of D. Okay, we wanted to get it in order. So C, D, well, we got D already. How did we get D? We said D and 140 degrees are vertically opposite angles. And because of that, their values are also the same. Now that we have got D, the next thing we want to look at is the value of what? Is the value of E. All right. So we say angle E, okay. We say angle E and angle 140 degrees. Well, we could use that approach. Or we could make it a little bit easy. So many ways. We could say D and 1E, they add up to 100 and what? 180. We could say E and 140 also add up to 180 degrees. Or we could simply say E and C are vertically opposite angles. And because of that, E and C are equal to each other. In that case, we would say E is equal to C. And because of that, what we then get, well, let's have this first with the caret. That is angle E is now equal to angle C. But notice that we already know angle C. We calculated it, it's 40 degrees. And because of that, we just go ahead and say, if that is the case, then angle C, okay, rather angle E, in this case, will be calculated by just substituting C with what? By just substituting C with, right, let me just have the what? The caret up. Okay, so we say angle E is this time equals to what? Is equals to 40 degrees. Why? It's because C equals to 40 degrees. So that is how we calculate the value of angle E. Now, the good news here is that once we have calculated the value of one angle, the other angles, we just don't need to calculate them. The other angles, we now use the relationship which is already created. Remember, Euclidean geometry deals with relationships. So we will be looking at relationships between these angles here, okay? The lines, the shapes, you know, the solids, the surfaces. These ones leads us to all that we are looking for. So now I would like us to consider this. So we will go in this direction, F, G, H. So we will want to look at this angle which is related to F. Once we have got the value of F, all these other one will be a lot easier for us. Which property are we going to use to find the value of F? Well, if we say F and H are vertically opposite, that is correct, but we don't know H. If we say F and G add up to 180 degrees, that is correct, but we don't know the value of G. We could instead say 15 and F add up to 180 degrees. And we do know the value of this angle, which is 15 degrees. And so to find the value of F, we would say 15 degrees added to F should give us 180 degrees. Okay, should give us 180 degrees. And if that is the case, we can find the value of F without much hassle. All right, then that means then, okay, let's first include here the degrees and also the degrees for this. Now, notice that from this one, okay, from this, we can now find the value of what? We can find the value of F. How do we then find the value of F? We find the value of F by transferring 15 degrees on the left-hand side to this side where there is 180. And that one would give us the value of what? The value of F. Why is that so? It's because F will be the only quantity on the left-hand side. And for this reason, we then say F, which is the angle we are looking for, is going to be equal to 180 degrees minus what? Minus 15 degrees. Okay, minus 15 degrees. That is 180 degrees minus 15 degrees. And from here, what is going to be the value of F? Well, the value of F is going to be That is, F is going to be equal to, what is 180 degrees minus 15 degrees? Well, 180 minus 15 will be 165 degrees. So we therefore say F equals to 165 what? Degrees. That's the value of F. Now that we have known the value of F, they are the quantities. It's going to be a lot easier for us to calculate. Why? Because we are simply going to use relationships. So after getting done with the value of F, the next thing we want to look at is the value of G. Now notice that G, that is angle G, notice that angle G is, okay, angle G is vertically opposite to angle what? 15 degrees. This G value is vertically opposite to 15. And because of that, they are also equal to each other. And so we can say G, that is angle G, is what? Is equals to 15 degrees. Yes, that is how we find the value of angle G. Now, the next thing we want to look at after angle G is angle H. Well, what relationship is going to make it easy for us to find the value of angle H? Well, the relationship is that angle H and angle F are vertically opposite. And because of that, they are also equal to each other. And therefore we say angle H and angle F, they are equal to each other. In other words, they are vertically opposite. And because of that, we can then calculate, rather we can just substitute F with the value that we calculated, which is what? Which is 165. And so from here, we make what? From here, we then go ahead, value of H, and what is it going to be here? Well, we will go ahead and say, for this reason, that these two angles are vertically opposite, H will take on the value of angle F, which is what? 165. Yes, 165 what? 165 degrees. That is going to be the value of angle H. We have got the value of F. We got the value of HG, rather. Now we have got the value of H. Now, the next thing here is, how about these other activities? Let's move like this. We are now moving anti-clockwise. So we are going to move to this. Well, notice that we have only one line here and another line here. Okay, two lines meeting to form two angles. Angle C and angle 89. How are we going to find these angles? Now, notice that angle C and angle 89, they are the only angles on this straight line here. And because of that, angle C and angle 89 add up to 180, rather, yes, add up to 180 degrees. What we are saying is that angle C and angle 89 will add up to what? 180 degrees. Okay, they will add up to 180 degrees. So here is the question. How do we then calculate the value of angle C? Well, the value of angle C will be calculated when we transfer or when we move 89 degrees from left hand side to the right hand side. And that will give us the next step in the solution. And so the next step will be, well, we then go ahead and say this angle C will then be calculated when we take away from 180, we take away 89 degrees. Okay, we take away 89 degrees. And so when we take away 89 degrees from 180 degrees, what do we get for that? Well, we would get a value which should be 81, is it 91 degrees? But let's make it a little bit easy. We are going to use a calculator to solve that. So we say in our calculator, 180 degrees minus 89 degrees, that would give us 91. And so we then go ahead and say C is going to be equal to, okay, angle C is going to be equals to 91 what? 91 degrees. This is how we calculate angle C. We then move to calculate angle B. Now, to calculate angle B, which property are we going to use? Well, notice that angle B and angle 20 degrees, they are the only angle on this one straight line. And so we say this angle B and this angle 20 degrees, they add up to what? They add up to 180 degrees. What we are actually saying is that B, okay, angle B added to angle 20 should give us the value of what? The value of 180 degrees. Okay, 180 degrees. That is angle B added, angle B added to angle what? To angle 20. Well, the next thing now is how do we find angle B? Now, in this case, we take away 20 degrees from left-hand side to the right-hand side. And when we do that, we will find the value of what? We will find the value of angle B. So we will in the next step be having, well, we will be having angle B now equal to what? 180 degrees minus 20 degrees. That is 180 degrees minus 20 degrees. And so from here, can we go ahead and find the value of angle B? Yes, we can go ahead and find the value of angle B. And what will it be? Well, it will be 180 minus 20, which is 100 and what? It's 160 degrees. That is going to be the value of what? The value of angle B. That is, angle B is going to be equals to 160 degrees. Yes, that is how we find the value of angle B. Then now finally, the question is about angle A. How do you find the value of angle A? Now notice that we are still going to use the same approach because we have one line here and on it we have angle A and angle 160 degrees. So what is that supposed to do for us? Well, that is supposed to let us know that angle A added to angle 160 degrees should give us 108 what? Degrees. Okay. So from here, we can then find the value of angle A. And how is that possible? Well, this is possible because we then have to transfer 160 from left-hand side to the right-hand side. When we do that, we will have angle A, okay? We will have angle A. now equals to 180 minus 160 degrees. And when we do that, we will then be able to isolate angle A on the left-hand side. And angle 180 minus 160 gives us the value of what? The value of 20 degrees. And so we can go ahead in the next step and conclude that angle A is going to be 20 degrees. Yes, this is how we do what? This is how we calculate the values of angle A, angle B, angle C, then all these other angles based on this other activity. So this now forms the what? The first concept on angle properties. And angle properties with activity 1, we have discussed a lot. And so from this, you should then be ready to have what? To have an activity to do by yourself, which should be coming shortly. So this is how we do what? This is how we calculate angles based on these properties that we just looked at. And then from that, you should then prepare for activities.